All right, in this video, we're going to look at simplifying trigonometric identities. Now, before we go, we must know a few different things. We need to be very, very, very comfortable with our identities. And by the identities, I mean double angle identities. I mean Pythagorean identities. If you know these things, feel free to skip ahead to the examples. However, I do want to just go over these real quick because these are going to be extremely useful in us manipulating these trigonometric identities. Now, along with these, we need to be very familiar with also our reciprocal identities. I'm not going to write these out because we should be very familiar that, 1 over sine of theta equals the cosecant of theta. All right, so we need to be familiar with all 6 of our identities, but I did want to write out our double angles and Pythagorean identities real quick because we will be using them in this video. So remember that my double angle for sine is going to be 2 sine of theta cosine theta. And then cosine double angle has quite a few different ones. We have cosine squared theta minus sine squared theta. We have 2 cosine squared of theta minus 1. And we have 1 minus 2 sine squared of theta. All right, tangent, I'll give you that one. Honestly, I don't really see this one used too much, but you never know. Could be a guy on the street asking you for the double angle of tangent. 1 minus tangent squared of theta. So that's extremely useful for us to know. My Pythagorean identities, these are also very common within these problems. We have the sine squared of theta plus cosine squared of theta equals 1. We have 1 plus tangent squared of theta equals secant squared of theta. And then we have 1 plus the cotangent squared of theta equals cosecant squared of theta. Now, with these problems right here, bear in mind that we can have any kind of form of this. And what I mean is if I see the sine squared of theta, it could also be 1 minus cosine squared of theta. Okay, so the whole point of simplifying trigonometric identities is being able to manipulate them in multiple different ways. This is a very, very good numerical analysis type exercise because it's starting to get us to see numbers in different terms, okay? So I want to jump into examples. You will need to practice these to get really good at them. Some people are going to be awesome at them at the very beginning, and some people will take some time. Don't get frustrated with these. Just keep practicing, keep practicing. First thing that I do is I always look at my reciprocal identities, and then I move into my Pythagorean and double angle to see if I can manipulate these functions in that way. So, example number 1. If I had this problem that said simplify the expression, and I had to simplify this, my first inclination is always to get my terms in terms of sine and cosine. I don't really care to see tangent or cotangent. I don't really want to deal with them. Sometimes we're going to have to. Sometimes it's easier to. But my first inclination is always to get sine or cosine. So I'm looking at cotangent, and I know that I can rewrite cotangent as, it's actually not equals, but I can rewrite cotangent as cosine squared over sine squared. So my problem now looks like sine squared of theta over cosine squared of theta times cosine squared of theta times or over sine squared of theta. Now, the whole point of this problem is to simplify, which means I can reduce my problem to make it smaller, to make it easier to work with. So now I know that when I multiply these fractions, some things are going to cancel. And in this particular problem, everything cancels, leaving me with a result of 1. That expression is simplified. I am done. My whole point is to simplify to get my problem smaller so that I can either easily work with it later on or whatever. So again, try to get everything in terms of sine theta, cosine theta. I see cotangent squared of theta. I'm going to rewrite that as cosine over sine. And then that makes my problem easy because I know that everything will cancel. Something, just kind of a sidebar here. I know that cotangent equals cosine theta over sine theta. And maybe this is a little confusing. With it being squared here, so I keep it squared, well, that's just going to make everything in my problem squared. It doesn't change my identity. Those are going to stay the same. But that only works for reciprocal problems. If I'm trying to do that stuff with the Pythagorean identity, if I had sine squared plus cosine, it does not equal 1. That's not the same thing, okay? So we'll see more of those as we move forward. So let's look at another one. So here, I see I have sine squared plus cosine squared plus tangent squared of theta. Now normally, I want to get everything in terms of sine and cosine. The reason I don't want to do that first here is I see everything is adding or subtracting. So I'm not going to be able to cancel stuff out like that last problem because that last problem was multiplying. So what properties do I know? What identities do I know that are adding and subtracting? Well, I know that my Pythagorean identities are adding. And then if you look, I have sine squared plus cosine squared. Well, that is 1. So I have 1 plus tangent squared of theta, which, again, if you know your Pythagorean identities, 1 plus tangent squared of theta is simply secant squared of theta. And that is my simplified problem. So again, normally I want to get everything in terms of sine and cosine. I don't want to do that here because everything is adding. All right? Look at the problem, try to analyze it a little bit to begin with, and see what works. You're always thinking of double angle. You're always thinking of Pythagorean. And you're always thinking of reciprocal. If you can start memorizing those different formulas, these will come a lot easier. But I'm looking for a way to go from bigger all the way down to something smaller. That's the point of us simplifying these expressions. All right? So let's look at another one. So here, I'll give us a little bit more room. Here, I want to simplify this expression. So now, because I have things that are multiplying and not adding, I'm going to try to get everything in terms of sine and cosine. So I'm going to rewrite this as sine theta divided by cosine theta times sine theta over cosine theta. Now, keep simplifying my problem here. I'll clean it up a little bit more over here. That's going to be cosine theta times sine theta over cosine theta. Well, I know that my cosines are going to cancel, leaving me with sine theta over sine theta, which is nice because I know those are going to cancel, leaving me with 1. And that's it. We've simplified our expression. So again, since everything was multiplying, just being a math teacher, my first inclination is to try the reciprocals. Sometimes you may get stuck and you may have to work something else out. But in this particular case, it worked out well. It worked out easy for us. We got our answer simplified. We went from big to something small. We have simplified our expression. So let's look at one more example. Simplify this expression. Now, normally, a lot of my inclination is going to be, okay, well, I could distribute that cosine, yada, yada, yada. I don't want to do that here. I see something is adding, so that tells me, okay, I see something adding. Let me look at my Pythagorean identities. Sure enough, 1 plus tangent squared of theta is secant squared of theta times cosine theta. Well, at this point, now, since I have two different terms, I can't do any Pythagorean identities. I can't do any double angle. So let's look at our reciprocals. So I know the reciprocal identity of secant is 1 over cosine squared theta. Remember, this is squared because secant was squared, right? So I've got to keep that squared in there. That's going to simplify to give me cosine theta over cosine squared theta. Well, that's going to cancel with one of these. So I'm left with 1 over cosine theta, which simplifies to give me, I'm going to keep the equal signs out because we're not working with an equation. 1 over cosine theta is secant theta. And that's it. We are done. So, and also actually, just for fun, notice maybe some of you wanted to convert from this point here. Maybe you wanted to say, well, what if I wrote cosine theta as 1 over secant theta times secant squared of theta? That is perfectly fine. You could have simplified by canceling that and canceling one of those, giving you just secant theta. There are a few different ways to solve these problems. Again, some of you are going to see it right off the bat. Some of you may struggle, and that's okay. But try to look at these problems with those little standards I said first, the Pythagorean, the double angle. Look for addition stuff, look for multiplication, and then try to see what works best for you. Just remember, these types of problems, you've got to practice. Don't get discouraged. Math is not easy. Sometimes it does take practice. So, you're doing great. Keep trying. Thanks for checking out the video. I will see you next time.